today we are continuing to work with these translations of our trig graphs. The change is the calculator. I'm going to teach you how to do it in a calculator. Now, here's the thing. When it comes to graphing these trig graphs in a calculator, for some people, it's way easier. For some people, it's not so much. When it comes to your test, your quiz, I don't care if you graph it on paper, if you graph it on the calculator. I'm still going to be looking for the 8 things, which is where doing it on the calculator sometimes can be a little bit more tedious. But there are advantages of at least knowing how to do it on the calculator, which is why we're going through that today. Especially if you are someone who ends up continuing on with math, sometimes you just need to know what the graph looks like. You don't necessarily need to graph it all out and write all the things out for it, but by being able to put it into your calculator and see what the graph looks like, you're able to answer a lot of questions about functions that require trig. So, today's instructions are going to say graph the following. The equations that we graph are going to look very much similar to the ones we have been graphing. I'm still looking for those same 8 things. Now, when it comes to those 8 things, you can gather some of that information off of the calculator after you've graphed it, if that works better for you. Or, for the most part, you're going to want an idea of many of those things before you graph it anyway. So I'm still going to go through those items beforehand. Vert, or vertical shift. Does this one have one? Yes. How far? What direction? Up 1. Phase, also known as phase shift. Does it have one? How far? What direction? To the right 30 degrees. Midline. Where is it? Y equals 1. It was typically at 0. It moved up 1. Period. Why 120?
Because cosine is 360 divided by 3.
Because cosine is typically 360 divided by that 3. If it wasn't in degrees, it would be 2 pi divided by 3, which would just be 2 pi over 3. Amplitude. 4, the number in front. Does a cosine graph have asymptotes?
No.
And if it doesn't have asymptotes, I actually should also know the domain right off as well. No asymptotes means all real numbers. The fancy version looks like theta exists within the reals, but in all technicality, that's still all real numbers. It's just a fancy way of writing it. We still say it, all real numbers. Now, range, which is an R, you could technically do range before we graph it as well. A cosine function, is that the ones that are, it's going to be y is greater than or equal to and y is less than or equal to? Is that going to be the all real numbers, or is this going to be the one that's stuck between 2 numbers? Sine and cosine is stuck between. Anyone know what the smallest number would be? I heard -4 and -1, and neither of those are correct. I hate to break it to you.
-3. Because it's 1
negative 3, because graph moved up 1. And it gets its minimum by going to the minimum line, and the minimum line is an amplitude above and below that for minimum and maximum. 4 below 1, negative 3. Less than or equal to y, which is less than or equal to 5, because 4 above 1 is 5. Now, if you don't get those until after you graph it, that's okay. That is okay. Now, we're going to be graphing this in the graphing calculator, but when it comes right down to it, I'm still looking for a graph on paper. And that graph on paper, I'm still looking for 2 full cycles, which means I would still probably draw my xy axis the way that I've been drawing my xy axis. This time I'd probably give me a little bit more room above. Why does it make more sense to have more room above on this graph? Because the midline's above 0 because it moved up. I still typically would put the full period over here, the negative version of it over here, and break the graph into how many parts? 4. Labeling how many of them? Least every other. I personally do all of this stuff before going to my graphing calculator. If you're struggling with one of these items, you can always go do it after the graphing calculator. But we'll talk about that. Now, my y-axis, I typically go how high? Double the amplitude, or the number in front if it doesn't have amplitude. Above and below, midline. Amplitude's 4. Double it, I get 8. 8 above 1 is 9. So I want to go up to at least 9. 8 below 1 is negative 7. So I at least want to get to negative 7 on my graph. Now, I'll be honest with you. With a sine and a cosine graph, is it really the end of the world if I don't have the extra room above and below? No. So, okay. 3, 6, 9. I guess I'm going to count by 3s because it's the only nice way that 9's going to fit on there. I guess I could have counted by 2s. Negative 3, negative 6, negative 9. I ended up going a little bit beyond it, below, but that's okay. Now when it comes to plugging these in, that's really one of the main issues that people have with these graphs, and then trying to get the graph to show you what you want is the second issue. So, either way, I start by just grabbing my calculator. I get into my graphing menu. For the TIs, it's the y equals. For the Casios, I have to go all the way back to the main menu and find where it says graph, which for most of you is going to be 3. For me, it's 5 because I got a fancy Casio. Yes, fancy. It needs to be said that way. If it's not said fancy, it's not right. Okay. That was a beastly one that I'll put in later. Okay. For cosine of 3, theta minus 30 degrees plus 1. Okay. So far, if I were to plug that in, I'm guessing I'm starting with the 4, right? Probably the cosine button. Here is where things can go awry, depending on what calculator you have. Do you notice that the TI opened a parentheses and the Casio did not? Do I need a parenthesis there? Here's the thing. If I do not have a parenthesis there, then what my calculator is going to read when I start typing it out is it is going to read it as 4 cosine of 3, just 3, getting multiplied by theta minus 30. Is the 3 the only thing inside of cosine? No. So do I need parentheses there? Absolutely. The TI took care of it. The Casio, I need to open up a set of parentheses. Okay, open parentheses 3, open parentheses. The next thing that's there is theta. How do you think we get a theta on there? X?
There is an option for theta.
There is an option for theta on the X button. How do I get to it?
Isn't it alpha 3? Oh, for X, I don't know. There's an actual theta.
There's a what?
Right
Oh,
above 3, isn't that
hey.
a theta?
Cool. Never knew that existed. No.
Oh.
Any of those letters, just like this X right here, is just actually a placeholder for a number. You won't be here when I talk about that with the class. I will talk about that with the juniors at the end of the trimester a little bit more. Okay, if I click the X button, it only brings up X. It doesn't give me the option for theta, even though theta is on the button. Here's the thing. I put an X. Isn't this typically an X-axis? Do I treat it any differently by it being the theta axis? No. So does it matter if the calculator says X? No. X, it is. Minus 30. Close parentheses. Plus what? Except how many, if I do that, plus 1, how many open parentheses do I have?
Oh,
How many open? 2. How many closed do I have? 1. Open, open, only a single close. Where's the second closed one supposed to go?
after the one.
After the 1 or before the 1?
Before.
By putting it here, I'm putting everything that goes inside cosine. In all technicality, where do I stop having things inside of cosine? At the closed parenthesis. I need a second closed parenthesis there before my plus 1. So close the second parenthesis, then 1. If I click enter, then it'll keep all of those things. Oh. That sounds good. Always love when there's this O that's like impending doom O. Okay. Now here's the thing. Most of the time we would type that stuff in and then we click graph, right? Anyone see a problem? They're not the same graph. Should they be the same graph? Did I type them in the same way? Yes. Then they should be the same graph. I will tell you further, neither of them is actually the accurate graph. Okay, because of 2 things. First off, one of the things you have to be careful of if you're going to use your calculator graph is you have to make sure it's in the correct units. What units are we using for an angle? Degrees. I have to check that my calculator's in degrees, because if it's not in degrees, I've got a problem. How do I check what mode the calculator is in on my TI? Mode. Click mode. Am I in degrees? Yes. If not, I need to change that. And I'm going to tell you right now, you might have to go back and forth from degrees to radians. Note I said might. There's a way around it, which we'll talk about. Okay, so my TI is in the correct mode, but does that look anything like a proper graph? Not for cosine, no. So, that calculator still got an issue. My Casio I know is in the wrong mode. How do I know that? I've got negative 1.178 popping up right there. Is it possible that there's a number there and it be in degrees? Absolutely. Do I think it's right? So, how do I get and change the mode of my Casio? Hint, it's not a mode button. Main menu brings me back here. Nope. Option gives me the option to picture or pan. Nope. I need to get into the setup menu. So yes, shift and then the menu button. Now, there's going to be a lot of things here that are not typically here when we change modes because we're in the graphing. So it's going to give me all these graph things, but if I keep scrolling, eventually I'll find angle. And I need it in degrees. So dig. Exit back out. Now I draw and hey, it looks like that one now. Correct. Well, actually, no. It's not wrong. It's just not showing us what we want to see. Because remember that negative 1.1 whatever? In other words, this calculator is showing me like this tiny bit of my graph. Is that all the graph we want to see? Is that tiny little bit between my pointer fingers? No. So, we have to change our viewing window. On the Casio, when you're in your graph, you can just click F3, or when in doubt, click Shift. It'll tell you your options. Viewing window. On your TI window. Both of them have essentially the same things, but they won't both show up on screen at the same time because the .cam hates them. X minimum. On the x-axis, how small should I go? Negative 120, isn't type. X maximum, 120. X scale. No. Scale is how much you're counting by. 30. We are counting by 30s. Here, by the way, if your scale was 1, which many calculators default to 1, you will still see your graph. The only thing you won't see is these ticks. If you're okay seeing the graph without seeing those tick marks, I don't care if you change the scale. If you need those tick marks to understand what's going on, put the scale on. Y minimum. Now, technically I said earlier I should go down to -7. So I can put -7 there, or I can just match what I drew on my page. Which is what I'm going to do. Y maximum, 9. Y scale, we counted by 3s. Now on the Casio calculator, where I'm going to put in all those same things, they also give me this dot option. Don't ask me what it means. I don't know. Leave it alone. I have never learned what the dot means. Never. I've been teaching for 10 years. Never had to deal with it. Before that, I was in college for 4 years doing math and high school for 4 years doing math. I've been doing at least high school math for 18 years and I don't need to know what it was. You probably don't need to know what it is either. Okay, Y minimum was -9, Y maximum was 9, the scale was still 3. Then it gives me all these other things. I don't care about them either. Don't ask me what they are. I don't know. I don't know. I know a lot of things about the calculators. I don't know everything. Exit back out of it on my Casio. On my TI, I just go directly to graph. On my Casio, now I can click draw. And now, does that look like a cosine curve? That looks better. That makes me happier. Now, here's the thing. We had most of our information already. Could we have just graphed it by hand? Absolutely. What the calculator has allowed me to do is it's allowed me to not have to pay attention to, okay, does it start at its maximum, its midline, or its minimum? Did it flip over? Did I remember to do the phase shift? That's the big advantage of the calculator, is I don't have to think about those things when it comes to the actual graphing itself. But when it comes right down to it, do I still need to put my midline in there? Yeah. Do I need my maximum and minimum lines? No. Will they help me? Probably. Where is my maximum line? 5. Amplitude above the midline. My minimum line? -3, amplitude below the midline. And now I can look at my graph and say, well, maybe I don't know exactly which point is the quote-unquote starting point, which is not actually a thing, it's just what we wrote. I could tell that at the middle of my graph, it's on the midline. One tick over, it's at its maximum. Mid, min, mid, min, mid, mid, min, sorry, max. Max, mid. So, for the sake of what we're doing here, is graphing it on the calculator save you a lot of thought process? No. But what if all you needed to know was, I've got this function. Where does it hit a maximum? Would the calculator be helpful then? Yeah. So, I'm teaching you the calculator piece more so about what you can use in the future. Whether you prefer to use it in this class or not is up to you. Now this next one we're going to do a little bit of a different order. Let's say I forgot how to find all of these things. I know, it's a very, very sad position to be in. But let's say I forgot how to find all of these things. So instead, the only thing I remember how to do is how to type it into my calculator. We are going to explore how we can get these things from that. Now, first things first, I need to know how to type it into my calculator, which this one's a little bit different. So, I go back to my menu, get rid of what I had there. Okay, -2, -3, cosecant.
Opposite of sign.
There's no button. Close to what I was thinking, Jed. Jed said opposite of sign, and it's so close. I'm just picky about wording. It's not opposite, it's what?
Reciprocal.
Reciprocal. And I care about that because opposite of sign is actually sign inverse. Are sign inverse and reciprocal of sign the same thing?
No.
No. How do I write a reciprocal in 1 over the thing you're taking the reciprocal of? So, for cosecant, I'm going to do 1 over sine. I probably shouldn't jump directly to a 1. What should be in between?
Parentheses.
Either a parentheses or a times symbol. I don't care either way. I prefer a parenthesis. Some people do not. Okay. 1 divided by sine. Now it opened up a set of parentheses here. Do I need that? Yes, I need parentheses here. Then I've got 4 open parentheses. Theta is now an x minus. Okay, here's where I have to make a decision, by the way. I got pi over 4. That's in radians, right? Right? Okay, thank you. I was scared for a second there. Okay, I have to make a decision. I have to make the decision on if I really want to continue to go back and forth between degrees and radians on my calculator. Some of you would rather do that. Some of you would not. There is not a wrong answer to which way you do it. On your graph, I'm looking for things to be in radians. But if in your calculator you graph it in degrees and just know how it relates to the radian, that's perfectly fine. So, I'm going to grab my second calculator. I'm going to type in the things that I've already put in. I am going to do my Casio in radians. I'm going to leave my TI in degrees. So, in my Casio, which is going to be in radians, then I type in pi divided by 4. I close the parentheses that was there. I close the parentheses around sine, and I close the parentheses that was around what made it cosecant, that 1 divided by. So I need 3 closed parentheses.
We can't see the.
All I did was draw in closed parentheses.
I didn't know if you wanted to see.
On my TI, which I'm going to leave in degrees, I have to ask myself, pi over 4 in radians is how many degrees? 45 degrees. You need to either convert that, or isn't pi over 4 in your unit circle? So can't we just let the unit circle do the conversion for us if we need be? Yeah. So I put 45 and I do my 3 closed parentheses. Now, remember, I knew nothing about how to find any of these 8 items. Obviously, that's a lie. But in order to see a proper graph, I still need to mess with the viewing window. So I go to my window. On my Casio, I have to hit Shift, then to get to my window. Okay, X minimum. In degrees, when in doubt, what's a good number to go with? What do you think? Minimum, negative, 360. When in doubt, put the typical period in there. And if it's in 360s, we'd be counting by like 90s. Here, -2 pi. Now my calculator's going to change it to a decimal because the calculator works in decimal, but that's fine. 2 pi. Scale, pi over, what's a quarter of 2 pi?
Pi over 4. Oh, that's just pi over 2.
Pi over 2. Because we break up, if this was our axis, if this we put over here was 2 pi, we broke it into 4 parts, this would be pi, and that would be a half a pi. That's why I'm asking this. Why minimums? I don't really know exactly how high it's going to be, so when in doubt, just pick some numbers that work that in your brain. I tend to go -10 to 10, and I just count by ones on the y-axis, because I can figure out counting by ones pretty easily. I screwed something up, didn't I? They don't look the same. It's not in radians. Good eye. Don't forget, if you're going to graph it in radians, you got to change it to radians. How they look alike.
What?
Okay, is this what we typically have been seeing? Yes-ish, but there's a lot more U's, aren't there?
Yeah.
Because remember, I just chose a generic number. Could I look at this graph and find the length of the period? Yeah. I know by looking at that there's an asymptote here. Now there's another asymptote here, but is that a full repeat of the graph from here to here? No, the full repeat comes here. So that's what they have as a full repeat of the graph. That is one tick mark. Wait a second. What was one tick mark again? What was our scale? 90 degrees or pi over 2. That was a full period. I know the period. Do I write 90 or pi over 2? Original graph was in radians. So I couldn't figure out the period by looking at the graph. If I then want to change my window, I can. Do I have to? No. But I can do that now. Negative pi over 2 to pi over 2. So now I see the graph a little more closely to what I would. And the scale would then be pi over 2 divided by 4, pi over 8. Or I can just do pi divided by 2 divided by 4, by the way. Calculator will do the math. Negative 90, 90, 90 divided by 4. Don't change the dot. Bad Benson. Okay, now that looks a little bit more normal to what we'd seen. We know what to put on the ends of our axes now. Other things I need. Midline. Y'all know that there's a trace button? Click trace. You can now move along your graph and see where things are. In fact, with your trace button hit, which both calculators have a trace button, the left and right arrows will move it left and right. If I notice that there's a low point here at a quarter of a tick, I can just say, okay, a quarter of the period was, well, I don't know, the period was pi over 2, so a quarter of that is pi divided by 2 divided by 4. If I just start typing that in, it'll give me the ability to move to that point. Since this one's in degrees, we said a full period was 90 degrees, and it'd be 90 divided by 4, and it'll bring me to that point. Along the bottom, it tells me the x value, which was at pi over 8, by the way, or on this one is 22.5 degrees. It gives me y is 1. Telling me, okay, I'm going to actually start drawing my graph now. I should probably start doing that. That'd be a good idea. Okay, this was pi over 2. This was negative pi over 2. Half of that is pi over 4. Divide into 4 parts. Pi over 4. Divide into 4 parts. I just figured out that my maximum line is at 1. I can also start typing in the negative version of it. Negative pi over 8. That gives me this. Tells me my minimum line is at negative 5. Okay, so that means I'm going to have to be a little bit above 1. So I'll just count by 2's. And a little bit below negative 5. I found my maximum line here. I found my minimum line to be here. What's in the middle of negative 5 and 1? Negative 2. That's my midline. It's called a midline for a reason. Now, the calculator for cosecant and secant and cotangent and tangent is not going to tell me my amplitude. It's going to tell me the amplitude for sine and cosine, which the amplitude would be the distance between the midline and the maximum. 3. Or for this case, it would be undefined. Remember, amplitude is always a positive, but it's undefined for anything other than sine and cosine. Was there a vertical shift? The midline was at -2. How did it shift vertically? Down 2. Calculator is not going to tell you the phase shift. So if the only thing you know how to do is type it into a calculator, you're not getting anything out of that. What is our phase shift here, though? Right, pi over 4. Now, from my calculator, where it goes from the very bottom to the very, very top, what's in between that is the asymptote for these. So my calculator can also tell me about my asymptotes. I've got an asymptote in the middle. I've got an asymptote 2 ticks over in both directions. In fact, I will also have an asymptote at the end points, because there's at the bottom and at the top. Also, because all the asymptotes are the same spacing. It's got upwards U's in the first and third areas. The upwards U's have to hit that maximum line. And it's got downwards U's between the second and the fourth. My asymptotes are at theta equals pi over 4 is the first one. Or I could have started at 0. I don't know why I didn't. Plus, how far apart are the asymptotes? Two tick marks, which is a pi over 4. K, and don't forget to tell me that K is an integer. Domain theta is not equal to the exact same thing. The calculator will not tell me that. You need to know the relationship between those. The calculator can tell me my range, though. Upwards, okay, technically the calculator can tell you the domain if you understand its relationship to the asymptotes, that is. But range, is this one of the ones that's above and below, stuck between, or everything? Above and below. Y is greater than or equal to what number? Where's the maximum line? 1. Or y is less than or equal to? -5. Now, I approached this problem as if we knew none of these things. Should we probably know how to find some of these things? Yes. Is it easier to find those things not from the graph? Yeah, in my opinion, yes. But my point is, you can work backwards as well if need be. Overall, my hope is that you either are graphing by hand, because that's what makes sense to you, or if nothing else, you're doing a little bit of a hybrid of the graphing, where you're getting this stuff, at least most of this stuff beforehand, and that the actual calculator is just giving you, where am I putting my U's, where am I putting my curve, where am I putting my swoops, as I call them for tangent or cotangent. Yes, they each have their own name. Is it actually a name? No. But generally, I go with something in between. Overall, when it comes to using the calculator, the amount you use it or don't use it is really up to you, though. The most challenging part, in my experience, is getting it into the calculator, though. So, the last thing we're going to do is just a couple more examples of how would this go into a calculator. we're not going to do the full thing. We're just going to say, how would it look when we typed it in? What things change? Parentheses. Where do I need to add parentheses? Before the 5 and after the other close parentheses. Assuming there was a second parenthesis. Just putting that out there. If there was no phase shift, there wouldn't have been a parenthesis. You'd end it after theta. Okay? What else changes? Theta becomes an x. What's one other thing you got to make sure you're doing now? Check that it's in degrees. Especially if you are using one of my calculators. Even if you are a person who chooses to always leave it in degrees, understand that those are community calculators and other people might choose to change that calculator. Negative cotangent of 4 times the quantity theta minus 5 pi plus 2. This time you need to check that it is in radians, or if you prefer to leave it in degrees, you need to convert the 5 pi into degrees. Keeping in mind that the stuff I'm looking for on your graph, I'm still looking for things in reference to radians. So when you label your axes, you still would have to put radians. But if it helps to put it into your calculator in degrees, you can do that. Okay? What would change in what I actually type in? Cotangent turns into 1 over tangent. What else? Theta is x and parentheses starting before 4 and ending after. The 2 is not in the cotangent. So, negative. I tend to put a parenthesis. 1 divided by tangent, open parenthesis, 4. Open parenthesis, x minus 5 pi, close parenthesis, close parenthesis, close parenthesis. Because there are 3 opens, all just trying to get me the cotangent, plus 2. Try that one out.